Okay, welcome back once again to all my dear students. Last time we had discussed about the examples related to change in enthalpy, then formation enthalpy, then combustion enthalpy, right? Now today we are going to discuss our next topic, that is the second law of thermodynamics. So let us start about second law of thermodynamics. As you all know, then what is the first law? That the energy can neither be created nor be destroyed, and the total amount of the energy will remain constant in the universe, and the one form of energy will be converted into the another form. That we had discussed in the last video. Now today we are going to discuss about the second law of thermodynamics. So let us start. Second law of thermodynamics, right? Second law of thermodynamics. Second law क्या है? The second law of thermodynamics explain in which direction either the forward or the reverse the reaction will occur spontaneously. Second law क्या कहता है कि किस डायरेक्शन में रिएक्शन स्पॉन्टेनियसली अपने आप होती है, कि either it will be in the forward or it will be in the reverse, right? And this law can be mentioned in the two different things. That first of all, that is in all the spontaneous process the entropy of the universe is increase. कोई भी अपने आप रिएक्शन होती है तो उसमें एंट्रोपी इंक्रीज होगी. यहाँ पे एक नया पैरामीटर आया कि एंट्रोपी किसको बोलते हैं. फिर बाद में द फ्री एनर्जी ऑफ द सिस्टम इन ऑल द स्पॉन्टेनियस रिएक्शन इज डिक्रीज. तो फ्री एनर्जी किसको बोलते हैं? तो ये सब आज हम डिस्कस करेंगे. दैट इज व्हाट इज एंट्रोपी, राइट, एंड व्हाट इज फ्री एनर्जी. सो फर्स्ट ऑफ ऑल, दैट इज द सेकंड लॉ ऑफ थर्मोडायनामिक्स एक्सप्लेन the second law of thermodynamics explain. क्या explain करता है? In which direction, either in which direction either the forward or either the forward or the reverse direction or reverse the reaction will occur spontaneous, or reverse the reaction occur spontaneous. Understand? Okay. Now यहाँ पे पहला पॉइंट दिया हुआ है कि in all spontaneous reaction or process the entropy of the universe is increased. I can write down in all spontaneous process the entropy of the universe, the entropy of the universe is increase, right? Is it clear? ये increase होता है. And second point, it will be given that the free energy of the system in all spontaneous process is decreased. The free energy of a system in all the spontaneous reaction, in all the spontaneous reaction or spontaneous reaction is decrease, right? यहां पे दो पैरामीटर हमको पढ़ने हैं इस लॉ में, एंट्रोपी एंड फ्री एनर्जी. In the first law of thermodynamics we had discussed about the internal energy, that is a delta U, and enthalpy, that is a delta H, right? तो इस लॉ में हमको क्या पढ़ना है? तो एंट्रोपी और what, that is a free energy. Now let us start the next point, that is if a two substance having a different temperature are kept in the contact with each other. अगर दो substance का temperature different है और उस दो सब्सटेंस को एक दूसरे से कांटेक्ट में हम रखते हैं तो क्या होगा, द हीट विल ऑलवेज बी स्पॉन्टेनियसली फ्लो फ्रॉम हायर टेम्परेचर टू लोअर टेम्परेचर। हमको मालूम है कि हीट विल बी स्पॉन्टेनियसली अपने आप फ्लो होगी, कहां से, जिसका टेम्परेचर हाई है वहां से लोअर टेम्परेचर तक, राइट। सो आई कैन राइट डाउन, इफ टू substance having a different substance having different temperature, different what temperature are kept, temperatures are kept what in contact with each other, in contact with each other, right, then the heat will always spontaneously flow, then the heat will always spontaneously flow from higher temperature to lower temperature, from higher temperature to lower temperature। इसको हम क्या बोलते हैं, जीरो लॉ ऑफ थर्मोडायनामिक्स। और ये हीट कब तक फ्लो होगी, जब तक दोनों सब्सटेंस का टेम्परेचर इक्वल ना हो जाए तब तक, राइट। सेकेंड पॉइंट, वाटर ऑलवेज फ्लो फ्रॉम हायर लेवल टू लोअर लेवल, एज यू ऑल नो वाटर always flow from higher level to lower level, understand, right। क्योंकि पानी है तो अपर से डाउन अपने आप फ्लो होता है, पर डाउन से अप इट कैनॉट बी अकर ऑन इट्स ओन और स्पॉन्टेनियसली, अंडरस्टैंड। सो ऑल दीज थिंग्स यू हैव टू नो, राइट। सो दिस इज द बेसिक concept of second law of thermodynamics. After that we are going to discuss about the entropy and the second law of thermodynamics, okay। so note down all these things। चलो अब देखते हैं एंट्रोपी एंड सेकेंड लॉ ऑफ थर्मोडायनामिक्स, ओके। नेक्स्ट पॉइंट दैट इज एंट्रोपी एंड सेकेंड लॉ ऑफ थर्मोडायनामिक्स, थर्मोडायनामिक्स, राइट। यहां पे देखो, अब पहले तो वी अंडरस्टैंड द टर्म एंट्रोपी, फिजिकल फॉर्म एंड देन आफ्टर मैथमेटिकल फॉर्म। पहले तो फिजिकल फॉर्म में हम अंडरस्टैंड करते हैं कि व्हाट इज एंट्रोपी। फर्स्ट ऑफ ऑल, बिफोर डिस्कसिंग द एंट्रोपी यू हैव टू नो दैट व्हाट इज टेम्परेचर। टेम्परेचर किसको बोलते हैं? वी नो दैट द टेम्परेचर ऑफ सब्सटेंस डज नॉट एक्सप्रेस द क्वांटिटी ऑफ हीट, टेम्परेचर डज नॉट एक्सप्रेस द क्वांटिटी ऑफ हीट बट the level of thermal energy in the substance। temperature किसको बोलते हैं? the level of thermal energy in the substance, right, and that is depends upon the zeroth law of thermodynamics। अभी हम बात करेंगे एंट्रोपी की। चलो, एंट्रोपी किसको बोलते हैं? तो एंट्रोपी that is the measurement of randomness of a substance। let us see, entropy is the measurement, what, measurement of randomness of a substance, right, of a substance। इसको हम क्या बोलते हैं? एंट्रोपी। एज फॉर एग्जाम्पल, इसका क्वेश्चन अगर यहाँ पे रैंडमनेस किसको बोलते हैं, तो चलो एक एग्जाम्पल लेता हूं कि अगर ये एक बॉक्स है और इस बॉक्स में 4 डिफरेंट स्क्वायर है। यहां पे दूसरा एक बॉक्स है जिसमें 9 डिफरेंट स्क्वायर्स आते हैं। यहां पे देखो 1 2 3 एंड 4, यहां पे 1 2 3 4 5 6 7 8 एंड 9, राइट। यहां पे अगर इस पेपर पे हनी बी घूम रही है, तो यहां पे अगर हनी बी घूम रही है तो यहां पे प्रोबेबिलिटी क्या होगी, इट विल हैव द 4 डिफरेंट प्लेस, राइट। बट यहां पे अगर वो घूम रही है तो द प्रोबेबिलिटी विल बी मोर। सो यहां पे रैंडमनेस ज्यादा होगा, और जिसकी रैंडमनेस ज्यादा है उसका एंट्रोपी इज ऑल्सो मोर, राइट। सो विद द इंक्रीज इन द रैंडमनेस द एंट्रोपी इज ऑल्सो इंक्रीज। तो अगर मैं एग्जांपल लेता हूं कि ये सॉलिड है, देखो ये सॉलिड सब्सटेंस है, ऑल द पार्टिकल्स आर क्लोजली पैक्ड एंड देयर इज नो रैंडमनेस, दिस इज सॉलिड, राइट। यहां पे मैं लिक्विड लेता हूं, चलो बीकर ले लिया और यहां पे लिक्विड है, तो रैंडमनेस तो है पर यहां पे सॉलिड से ज्यादा, तो दिस वी कैन से इट इज अ लिक्विड। एंड थर्ड वन दैट इज गैस। गैस में क्या होगा, राइट, तो ये गैसियस स्टेट है। तो यहां से मैं कह सकता हूं कि सॉलिड में रैंडमनेस नहीं है, लिक्विड में सॉलिड से थोड़ी बहुत ज्यादा है, और गैस में इट इज मोर रैंडमनेस। So as the randomness will be more, then we can say that the entropy is also increased. Why? Because the entropy is the measurement of randomness, right? तो जिसमें randomness ज्यादा होगी उसकी entropy भी क्या होगी, ज्यादा। Understand? Is it clear? So note down all these things. और यहाँ पे जैसे हम वॉल्यूम इंक्रीज करेंगे तो क्या होगा, let us suppose the volume of the gas increase when the gas is filled in one bulb is connected with the another evacuated bulb, then which means that the molecules of the gas has a more space is available, right। अगर ये एक बल्ब है, यहाँ पे मैं एक बल्ब लेता हूं और यहाँ पे दूसरा बल्ब लेता हूं, यहाँ पे एक वाल्व कनेक्ट किया हुआ है, राइट। यहाँ पे देखना, यहाँ पे गैस भरा हुआ है and this is evacuated, right। अगर मैं ये वाल्व को ओपन करता हूं, if I open the valve, तो क्या होगा, ये गैस यहाँ पे फ्लो होगी, so that the volume will be increased, and as the volume will be increased then we can say that the randomness is increased, and जब randomness increase हुई तो we can say that the entropy is also increased। Understand? So that you have to know that with the increase in the volume we can say that the entropy is also increased। और एंट्रोपी किस में ज्यादा होगी, गैसियस स्टेट में। क्यों? क्योंकि जो भी मॉलिक्यूल्स गैसियस स्टेट में है दे आर अवे फ्रॉम ईच अदर, देयर इज अ मोर रैंडमनेस इज देयर, और जिसमें रैंडमनेस ज्यादा है उसकी एंट्रोपी भी ज्यादा। अंडरस्टैंड? सो दिस इज ऑल अबाउट द फिजिकल स्टेट, that what is about the entropy. Now we are going to discuss about the mathematical step, right? First of all, note down all these things. चलो नाउ मैथमेटिकल स्टेप देखते हैं। ओके, एंट्रोपी इज एक्सप्रेस्ड बाय सिंबल एस। एंट्रोपी इज expressed by the symbol that is S, right? S is the symbol. Entropy is a state function. Second one we can say entropy is a state function. Third point we can say that it depends on the mass of the substance. It depends on the mass of the substance, right? Is it clear? And in the other word we can say that the entropy of 1 mole of substance has a constant value of at a constant temperature and pressure. So we can say the entropy entropy of 1 mole of substance, of 1 mole of substance has constant value, at constant temperature and pressure, at constant temperature and pressure, right? Okay, now we can say that the change in the entropy, how it will be expressed as the change in entropy is expressed as delta S, and delta S, that is the what? Delta S, what? Final state minus initial state. Final state minus delta S, or S initial state. Understand? Is it clear? So here I can also write down that delta S, that is equals to S final state minus S initial state, right? And that is equals to what? Q reversible by T. Understand? Right, where Q reversible is the heat obtained or heat loss by the system, where Q reversible is the heat obtained or heat lost, what? By the system, understand? At temperature T, at temperature, that is a T, understand? Okay, and it will be measured, let us suppose if this will be measured in joule and this will be measured in Kelvin, understand? So the unit of delta S, that is a joule into Kelvin inverse. So unit of delta S, that is a joule Kelvin inverse, understand? So all these things we have to know. Okay, so this is all about the entropy, right? And here let us suppose the entropy, as you all know that here if I write down that to determine whether the reaction will occur spontaneous or not, then how I can find out? That this depends upon the entropy, right? As for example, that यहाँ पे मैं लिखता हूँ कि first one, that is delta S system plus delta S surrounding is greater than 0. Delta S system plus delta S surrounding अगर 0 से ज्यादा है तो we can say the reaction will occur on its own. The reaction will occurs on its own, right? अगर delta S system plus delta S surrounding less than 0 है, means it will be negative, then the reaction will not occur on its own. The reaction will not occur on its own, right? And last one, that if delta S system plus delta S surrounding equals to 0, then we can say the reaction will remain in equilibrium. The reaction will remain in what? Equilibrium. Understand? So note down all these things. This is all about the entropy, right? Note down. Okay, now next one, that is in entropy only, right? The change in entropy of the system, the change in entropy of the system, what of the system when solid is changed to liquid state, when solid is changed to liquid state, liquid state, right? That is called fusion at constant what temperature, or when liquid is changed to gaseous state, or when liquid is changed to gaseous state, that is called vaporization at constant temperature, are called molar fusion entropy, are called molar fusion entropy and molar vaporization entropy, right? And molar vaporization entropy of substance, and molar vaporization entropy of substance, right? If I write down here, then I can write down delta H equals to Q reversible, अभी हमने देखा, and what delta S equals to Q reversible by T, right? So I can put here, so delta S equals to delta H upon T, right? So I can write down here delta S fusion equals to delta H fusion upon T, or you can say delta S vaporization, that is equals to delta H vaporization upon what? T. Okay, and sublimation, that it directly changed solid to gas, so I can write down that delta S sublimation, that is equals to delta H sublimation upon what? T. Okay, so this is all about the entropy. Okay, so note down all these things. Okay, now let us see that change in the entropy can be expressed as, I can say that delta S, that is equals to what? Total entropy of product, total entropy of product, that is the SP, minus total entropy of reactant, total entropy of reactant, and that is a SI. Understand? Now increase in entropy with the increase in the temperature. How? Increase in entropy with increase in temperature, increase in टेम्परेचर। चलो कैसे इंक्रीज होता है? अगर मैं टेम्परेचर को इंक्रीज करता हूं तो एंट्रोपी भी इंक्रीज होगी। क्यों? विद द इंक्रीज इन द टेम्परेचर वी कैन से द ट्रांसलेशन मोशन एज वेल एज द रोटेशनल मोशन एंड वाइब्रेशनल मोशन इज इंक्रीज, राइट? I can write down here with increase in temperature, three different motion is there. That translation motion, the translation motion, as well as what? Rotational motion, rotational motion and vibrational motion increase, and vibrational motion increase, right? And so there is an increase in randomness, right? And so there is increase in randomness, राइट? अगर मैं टेम्परेचर को इंक्रीज करता हूं तो सॉलिड का लिक्विड, लिक्विड का गैस, तो गैस में रैंडमनेस ज्यादा है, सो वी कैन से अगर रैंडमनेस ज्यादा है तो वी कैन से दैट द एंट्रोपी इज आल्सो इंक्रीज, राइट? एंट्रोपी इज आल्सो अ स्टेट फंक्शन लाइक इंटरनल एनर्जी एंड एंथैल्पी. एंट्रोपी is also a state function like internal energy and enthalpy, right? दोनों state function. Hence the entropy change will depends on initial and final state of system, and that's why we can say that if the randomness, there is a delta S that is equals to SF minus SR, right? And that is greater than 0. Understand? So that we can say it is a entropy, that is a SF minus SR. Okay, so or you can say SF minus final and minus initial. Okay, now यहाँ पे explanation of ideal gas in the vacuum and change in the entropy. चलो, when vessel is filled in 1 mole of ideal gas, अगर कोई भी vessel में अगर 1 मोल ideal gas fill किया हुआ है, right, is connected to the evacuated vessel, then there is no work done by the system during the expansion of the gas on its own, right? So now write down that first of all, when a vessel is filled with 1 mole of ideal gas, when 1 minute. Okay, first of all note down all these things, right? And then after we are discussing about the expansion of ideal gas, right? चलो, now expansion of ideal gas in vacuum. Expansion of ideal gas in vacuum and change in entropy and change in what? Entropy. ओके, चलो देखते हैं. यहां पे देखो पहले, when a vessel is filled with 1 mole of ideal gas, when a vessel is filled with 1 mole of ideal gas, right, is connected to an evacuated vessel, is connected to an evacuated vessel, right? Okay, so there is no work done by the system there is no work done by the system, कोई भी वर्क बाय द सिस्टम्स में नहीं हो रहा है ड्यूरिंग द एक्सपांशन ऑफ द गैस ऑन इट्स ओन, ड्यूरिंग द एक्सपांशन ऑफ गैस ऑन इट्स ओन, गैस का क्या होगा, एक्सपांशन होगा अपने आप, बिकॉज W इक्वल्स टू P इंटू डेल्टा V, बिकॉज P into delta V, the value of P is 0, right? The value of P is 0, right? Because of vacuum, क्योंकि ये vacuum की बात कर रहे हैं, because of vacuum, okay? So there is no work is done. So in addition, the gas does not lose or give the heat in this process. Thus, the gas does not lose or give the heat in this process, right? Is it clear? Hence Q equals to 0. Hence Q that is equals to 0, which means the internal energy is also 0. Okay, and thus we can say this process is not reversible. This process is not reversible. Is it clear? Hence Q irreversible will be 0. Hence Q irreversible, that is also 0. And that's why we can say that for ideal vacuum P equals to 0, so delta U is also equals to 0 in the vacuum. Okay, so यहाँ पे अगर मैं लिखता हूँ as the volume of the gas increase during a reversible process, as the volume of the gas increase during what, reversible process, right? The change in entropy will be there. So the change in the entropy, is, let us see that यहाँ पे मुझे मालूम है कि Q reversible by T that is equals to what, or I can write down Q reversible that is equals to RT ln V2 by V1, ln V2 by V1. So I can write down here Q reversible by T that is equals to R ln V2 by V1. Understand? So Q reversible by T, this we can know that is equals to delta S. So I can write down delta S equals to R ln V2 by V1. Understand? V1 is the initial volume of gas, V2 is the final volume. So I can write down V1 is the initial volume and V2 that is the final volume. Understand? Is it clear? So according to the Boyle's law, you all know that P1 V1 equals to P2 P2. So I can write down here that P1 by P2 equals to V2 by V1. So I can write down here this way, delta S equals to R ln what, P1 by P2. Okay, so instead of this I can also write down delta S equals to 2.303 R log P1 by P2, or you can also write down this as a delta S equals to 2.303 R log what, V2 by V1. Understand? So this is how, this is all about the change in entropy, right? So if any example will be asked, then you have to put the volume will be given, then you put here, thus you can get the change in entropy. Okay, but आपको ये मालूम होना चाहिए कि entropy means what, दैट इज अ रैंडमनेस. जिसमें रैंडमनेस ज्यादा है उसकी एंट्रोपी भी ज्यादा होगी, एंड विद द इंक्रीज इन द टेम्परेचर द रैंडमनेस इज आल्सो increase. Okay, so up to here it's enough. In the next video we are going to discuss about what that is a Gibbs free energy and second law of thermodynamics. Okay, so thank you very much.